Hey, what's up? Want to come on here and talk about Advent of Code day 6 in my solution or my attempt at a solution. Okay, what's the problem? So the problem is that it's actually a pretty cool one. You the story is that like you can travel in time and there's this guard patrolling this lab. Um, but you can't like you got to make sure that the guard can't see you. And so you have to create a path, and the guard moves around, or you have to look at the path that the guard moves. And basically, so this is the map. Okay, these dots, they're just sort of pretty much empty space, like nothing there. These hashtags, they're like obstacles, and this symbol here is the guard, and he has two rules for movement. If there's something directly in front of you, like one of these objects here, turn right 90 degrees. And then otherwise, just take a step forward. So he's gonna, jump up, hit this thing here, turn right, go right, hit this, go down. And so, once he's made that path, you'll have to figure out all the spots that he's been to, all the unique spots. And these are all just like coordinates on a matrix, right? So we just count these up, count up the unique positions that the guard has been to, sum that up, and in this example, it's 41. And that's the answer. So let me go ahead and show you what I did for my solution. So this isn't my proudest work, but I tried to keep it somewhat neat here and somewhat legible. I will say that this problem today was definitely the most difficult one that I've done so far. But here's basically how this is going to work. Oh, and I learned a little bit of this library called curses. And what curses will do is actually allow us to kind of draw an interface on the command line here. So I'll show you what that looks like now, because I'm pretty proud of it. Let me zoom in a little bit, make this more legible. Oops. Oh, there you go. Here, maybe I can make it even bigger. Yeah, there he goes. Okay. Just for fun, just a little visualization thing to do. I've seen a lot of people do some pretty sick stuff. On like in the Advent of Code, like subreddit and on the Discord when it comes to the visualization. But I learned how to do that, and it actually made things a lot easier to debug this with. So the main loop. So I'm actually just gonna get rid of that now, because I don't need that. I don't need to be concerned with that loop. This loop here will just calculate the answer, no visualization. Let me close that. So yeah. Okay. So the main thing here is this loop. So we take this map, and for the example input, I just sort of hard coded it here. We take this map, we're gonna, based on those rules, update it with this function called update lab. And if it comes back void, that means that the guard has sort of gone out of bounds and he's found an exit. And then we'll print this set here visited, which is just going to keep track of the of all the positions that the guard has been to. So let's look at this function here, update lab. So we have some important global variables here. So talk about this in just a second. But so the guard position, the first thing we're going to want to do is find where the guard is. And then so we just pass in the map and the direction. The direction, he's either going to go up, down, right, or left, right? So he's going to be any one of these symbols. So if we go to get guard position, yeah, so it's going to look through the map, simple nested for loop, and if we found it where he's that symbol, if that element in the matrix is that symbol, we're just going to give back the coordinates. So that's how that works. And then we're going to add to our set here that position. And the next thing we're going to do is look at the next object, sort of the next thing that he's going to look at. So for example, here, the next thing that he'll see is this dot, and that's not something we're going to be concerned about, because we're checking if it's one of these hashtags symbols. Because if that's the case, then this is where we're going to actually start applying the rules. So the index here, we change it to 1. It starts off at 0, and we start off with this symbol, and these are our directions. And you can see this array of directions. It's just an array of these characters, but it's just to represent up. It goes in clockwise order too. That's very important. Up, right, down, left, because we're going to update this symbol based on this, his direction. And so this is going to add 1 each time, and we're going to modulo 4 so that we're going to circle back around through this set, through this array. And then we're going to get the next position that the guard will travel to. So we found him, we looked at the thing that we're going to see, and then based on that information, where is he going to go next? And we do that in this travel function I'll talk about in just a second. And then if he's gone out of bounds, and then we're just going to stop this this updating and return, and it'll come back void on the other end. But if that's not the case, we're going to update the map to reflect these changes. We're going to put the guard in his new position. His symbol, if it's different, that'll update as well. Yep, and then the guard position is going to equal the next guard position. And then we're just going to give back that the map, this lab map, once we've done all those changes. So let me talk about this function here. I called it get adjacent object. So we're looking at the map position that's given and the direction. So all this is saying is that if he's facing this way, up, then he's just going to go up. If he's facing down, he's going to go down. It's just, calculated based on these coordinates here. And if that's not out of bounds with his new position, then we're just going to give exactly whatever that element is at that new position where he's plans on going to next. So hopefully that makes sense. And then the travel function, it's pretty similar. It's just taking in that tuple of positions, and then same thing. Is he facing up, right, down, or left? and then just modifying that tuple or the values of that tuple to this, changing it to this. Because you actually can't modify tuples because they're immutable, obviously. But we're gonna return this new position. So yeah, this part didn't take me too long, and this is boring. Just how getting the actual input into this wasn't that difficult, and that's how I did it. But yeah, this actually works, and I was able to get that cool little animation going too. So that was part one, and actually I did it. I solved that puzzle. And then there was part two. Part two was a bit of a different story. Unfortunately, I didn't finish it because my approach is very inefficient. I'm looking at it right now. I actually programmed in a way to keep track of where I'm at. It's almost embarrassing how bad this is. I'm at 0.08%. But anyway, part two is so taking this scenario, and now what if you add a new object? Because, you know, his movement rules are very simple, that there's a potential that if you add in a new obstacle, that he'll just get stuck in a loop. Right? So if you put the obstacle right here, this new obstacle here, if that were the case, then he would get stuck in the circle here. It's the same thing with this one. If you put the new obstacle there, you would go up here, doom, 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 doom. Yep, and get stuck in a circle right there. So that's the next part. It's like, okay, now where are the possible spots where you can put a new obstacle such that the guard will get stuck in a circle? So my approach to this, I'll just verbalize it, is basically look at the map and then look at all those empty spots. Start the simulation over if that spot was an object like this. So this will change into a hashtag, and then let it run. If he can get out of there, if he can still get out of bounds, sort of exit this area, then that one didn't work, and you'll have to move on to the next one. And then try that. And if that one, if you get to the point where, where's the first one? Yeah, the first one is all the way down here, I guess. If you get here, if you throw one here, you know, what does he do? Does he get stuck? And part of the issue was, okay, how do you actually calculate? How do you determine that he is stuck, that he's running around in this circle? Then my idea was just, it's already possible that he's going to hit a position maybe once or twice over the course of, you know, being able to exit out of this this map here. And so I just set it as kind of an arbitrary threshold. Like, if he's gone over this position like 10 times, he's probably stuck. That's just an assumption I made. So that was sort of how I approached it. So this is basically the same code, except that, here, I'll show you what I did. So this is a big difference. We're going to go through each of the elements of the map of the matrix. If it's a dot, we'll append that to our list of candidates. That's like a candidate spot. And let's see. Yeah, this kind of got messy. I was starting. I was starting to kind of panic. Uh, okay, yeah, here's the main thing here. For object and candidates, this or this, we're gonna add a new object by taking that original map, our original starting position, but then put that object in there at that position. Start everything over. And while the lab map is still valid and not void, because we're going to be calling our update lab function on it, and not running in circles. And this is a flag that we're going to check with this function called circle check. Just keep updating the lab and keep checking for if it's running in a circle. And if we break out of this, if lab map is not none, if it's not void, then we were just running in circles, and we can add that candidate object to our list of ones that actually work. That is called the best objects, and then we'll print just how many we found so far. So it worked on the example one, on the test one, but since the input size is so huge, it's not something instantaneous. It's like something, I guess, like maybe I'll run overnight and see where we get to. So I should be able to show this visualization I did that I made. Is it this one? It wasn't this one. Oh, wait. I have to change it back to example input. So let me comment that out. So, okay, here we go. Here's a little visualization of what I was doing. So as you can see here, this is the new object that we're putting in there and seeing what happens. As you can see, we run the simulation and he can still get out. And so this will probably take a while, and I guess I'll just end the video on letting this run. But I'll just say that this was not the most efficient solution, and so unfortunately today I only got 1 star. I'll come back to this tomorrow. Maybe I can make it a little faster, take some feedback. Maybe it'll finish running overnight, who knows. But yeah, if you have any advice for me, any feedback, if you'd like to just come on the show and talk about what you did, just let me know. Yeah, thanks for watching.